You can add dimensions to the square in this question, which I did. I called the lengths like 2, and hence the other one's 2, and worked out the areas and then divided through by 4 at the end. But you can actually do the question without worrying about any lengths. So I'm going to go through it that way. We want to find the area of this pentagon, but rather than focusing on the area of the pentagon, I'm going to focus on the area of the non-pentagon. First up, this area here. That is just going to be a half of the square. And that leaves us with 2 triangles to subtract, because I'm going to have like a whole amount, 1, and then I'm going to be minusing a half, and then we're minusing another fraction. So let's focus on these 2 triangles. And by the way, these 2 are exactly the same. You can sort of see that because they're constructed in the same way. They've got a length here that's a half of the length of the square. They're going to have a 45-degree angle here, both of them. And then for both of them, this angle is going to be the same. So they're definitely congruent. They are identical angle, side angle. I'm just going to focus on the top right one. Now there's another little thing to notice, and that this red triangle here is actually going to be similar to this green triangle. That's the key to this question, is really a similar triangles question. Because we know that these 2 angles are the same. And then you could say we've got like Z angles, I suppose. There's a Z going on, so those 2 are the same. Let me do that one in green. And then that one there, similarly, is the same as that one. Now, this is a full length, and this is a half length. So I know the red triangle is just half the size in terms of lengths of the green than the green triangle. And what that means is that, okay, because this plus this is a full amount, then this must be, I can split it into 3 now, because I can split, this is like 2/3 and this is a third, which means this area is going to be, well, we've got a half of the length, then I'm multiplying by a third of the width, and it's a triangle sometimes, and by a half, so it's 1/12 of the whole area. And then that one is also 1/12, so I have a half plus 1/12 plus 1/12. That's going to give me all of this, which is going to be that 6/12 plus 2/12, 8/12, or divide through by 4, 2/3, which means that hexagon is the remainder. 1 minus 2/3 is going to be a third. If you're less happy with what I did with that triangle, this is how I actually did it. I said that this length was 2, this is 1, and so it's double, like the green one is double. So if I call this one x, this is going to be 2x, and then I can say that 3x is going to be 2, so x is 2/3. And then that means the area of the triangle is going to be a half times 1 times 2/3, which is a third. But that is not the fraction, that is an actual amount now, so I then need to divide that a third by the total area, 4, which would again get me to 1/12. Or you can add all the areas up, like that area there would be 2, add it to the 2/3 and another 2/3, divide by 4, and that'll get you to this 2/3, and then do 1 minus that. There's different approaches, but anyway, similar triangles, carefully working through it. Our answer is a third. Nice one.